Hello and welcome to another video. As a data scientist, you may need to combine multiple data frames to do everything that you need to do and get enough data all in one place. And today we're going to talk about just that. We're going to import pandas as we always do, and then we'll import a few different data frames that we can combine. I made these up just for us to be able to play with combining data frames. So we loaded them in, and then let's look at the students and the names tables or data frames. So notice we have a student ID, a GPA, and a year. Down here we also have a student ID and a name. So over here we have a student ID and a student ID. They're spelt a little differently, but this is probably how we're going to match these two data frames up. You can imagine a situation where I want to know, based on someone's name, what their GPA and year is. But we have name and GPA and year are in two totally different data frames. But they both have student ID, so we can use that to match up the students to two different tables. There's only one catch though. Notice down here, this last column, we have ID 7, and down here we have ID 5. So 0 through 4 are the same, but then we have the 7 and this 5. And that's going to cause an interesting situation that we can look into. And so ultimately our goal here is to take one data frame and put it next to the other data frame, basically create a data frame with more columns. So one data frame that includes GPA year and student name. So there's a few different ways to do this. We're going to be talking about the merge method, pd.merge, and we have what data frames we want to merge, and then the left key and the right key is both, they're going to be the student ID and student ID. And that's basically saying what we're going to use as a key to match these up with. And the way we're going to be matching it up, or how, is with inner. We're going to talk about what that means in a second. And then we take all that and set it to a new data frame called inner. Same thing with outer, left, and right. And we'll talk about what each of those mean. But first, let's run this. So now we've loaded up all those new data frames. We don't see anything yet because we're just assigning data frames, but let's look at the inner data frame. Now notice we have only 5 rows, 0 to 4. That's because the 5 and 7 that don't match, those both just get dropped. So inner is only going to keep rows where the right and left both have a match with each other. So now I see we can match up Bob is a freshman with a GPA of 4.0. Very good work, Bob. And we can do that for all of these now that we've increased the number of rows that we have in our single data frame. Of course, it's a little redundant now to have student ID and student ID. That was something that was necessary to match up these data frames, but maybe not necessary now, so we can drop that. And there we go, we have our data frame. Now let's look at the outer data frame. It's kind of the opposite of inner, because inner gets rid of everything that doesn't have a match. Outer keeps everything. And so we notice that our student ID of 7 doesn't have a match in our other data frame, so it just gets filled with null values. And we'll talk in a later video about how to deal with null values. Also notice that our student ID of 5 in our other data frame doesn't have any matches in the first data frame, so that first data frame gets filled with null values, or NaNs. Now let's look at the left and right. So left is only going to keep, it's going to keep everything in the left data frame, filling in the right with NAs. But if there's something in the right data frame without a match, that just gets dropped. So it'll drop things in the right data frame, but keep things in the left. And the less commonly used right data frame does the exact opposite, keeping things in the right, but not the left. I say right is less commonly used because it's a little redundant. You can always just reorder your data frames to make it so that whichever one you want to keep is the left one. So that's pretty common to do, to just use left, but right definitely is an option if you so choose. So this is all the first way of combining data frames, basically putting them next to each other. But what if we want not more columns, but more rows? What if we want to make a data frame that's longer by combining data frames? Well, we can use concatenate. So let's look at students 2. We have essentially the same columns as in student 1, or in students. So what we can do is pd.concatenate, and then a list of data frames we want to concatenate, in this case students and students 2. So we'll concatenate those. And this resulting data frame will get displayed in our Jupyter notebook because it's the last thing in our Jupyter notebook cell. You may notice one issue with this is that it goes from 0 to 5, the index, and then 0 to 5 again. This may not be desirable. So what we can do is then ignore index equals true. And that'll fix that problem for us, going from 0 to 11. And that's really all there is to it for combining data frames. Thanks for sticking around to the end, and I'll see you in the next video.